Alright guys, Mr. Cubic here. I really like this method. It's funny, I have all these things I didn't know how to use, and now as a result of the plague, I am getting good at them. So I'm just doing this so you can see that I'm here. I did want to tell you guys I was really very proud of how you guys did on Chapter 10. Chapter 10 was kind of a nice one for us to do in the sense that it was good for us to get our feet wet. I will tell you that the stuff we're doing here in Chapter 11 is incredibly important. Now, again, most of it is review, but please, whatever you're doing, if for some reason you were struggling with some things, make sure that you are taking notes, I would suggest. I would say you can pause this at any time. One nice thing about this is you can go back and you can re-watch your videos, which is something that's a great idea. But I was very proud of you. I know this is hard. I know it's hard to focus. So I would tell you, please stay patient. I'll try and keep these as short as I can, and we'll go from there. So that's my 2 cents. I'm going to zoom myself out of here. Okay, and now you can just look. So these are our notes for 7 April 2020, and we're talking about rational square roots. So we have our notes are sitting right here. I think you should be able to read them. I wish it was a little bit bigger. Maybe I'll fix that if you can't see this. Okay. So I have here one thing that you should have is at least have the first 15 square roots in your head. But I would suggest that you just memorize the first 20 square roots. So I'm doing this one so you can see why they're called perfect squares. Okay. They're called perfect squares because these are just all the whole numbers squared, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So if you don't know any of those, you stink. Okay? Now you should know these, right? 11 squared is 121. Okay? 12 squared is 144. Okay? So one interesting bit of trivia. Okay? So 12 squared is a dozen dozens, right? So 12 dozen, a dozen dozens, has a name. It is called a gross, right? So you could say to somebody, your face is a dozen dozens. Boom. Crushed. Cry yourself to sleep. 13 squared, 169. 14 squared is 196. So I always kind of thought those are interesting because, right, you just transpose those second numbers as you go from one to the next. 15 squared is 225. Now, I'm going to be honest with you, these other ones I'm a little rusty on, but after the end of this chapter, I'm usually pretty good. Okay, so 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Now, I will tell you, I know 17 squared for some reason, and 20 squared I know. The other ones I have written down next to me, so I can just act like I'm smart. Okay, so the big thing about these perfect squares is, if I ask you to find, right, the square root of any of these, it's just sort of like going from the red to the black. So here, right, I have the directions for the first part of it. I started with some easy problems, right? And so the easy problems I have here, right, is I just say, right, what is the square root of 4? Now I'm going to tell you something, right, I would just say root 4. There are other roots besides square roots, but if you don't say anything, you're always going to assume it's square root. So I would just say root 4. So what's root 4, right? Well, I just kind of in my head know that 2 squared is 4, right? So root 4 is 2. Now I want you to understand, it is not plus or minus 2, okay? It is positive unless otherwise noted. So this is one thing Saxon teaches that's flat out wrong. Okay? I always get in this debate as we teach it. Okay? So here, right, we have an example. So plus or minus root 144. Okay? So I just went over that that's a gross, a dozen dozens. So this would be equal to, right, root 144 is equal to 12. But you'll see they told us specifically it's not just 12, it's plus or minus 12. Okay? So that is an important thing that you guys understand. So the answer here is plus or minus 12. Now, the next one here maybe looks hard. Okay? It's root 361, the negative of that. But, right, if I go up to the top, 361 is 19 squared. So that's why it's nice to have at least up to 15 memorized. It just makes your life easier, right? But I would suggest up to 20. 361, okay, is 19 squared. So this is going to be minus 19. Now look, again, right? You're like, oh, it's always positive. No, this one's negative, right? This one's positive, right? So it's almost like just go with the sign they tell you to put there. All right? So these are easy, okay? So now I'm going to move on to a medium, okay? And I'm going to show you why this is a medium. I don't think it's particularly hard, and I don't think you will either. But so let's say I'm like, I got no idea what root 625 is, okay? So again, this is something you did in Saxon ad nauseum, right? Like literally, that's Latin until you throw up. So I know that it's 5 times 125, right? Which tells me that that is 5 times 25. So here I have 5 and 5. So here I get 5 to the 4th power. So this would be root 5 to the 4th power, right? Which would be 5 squared. So the square root of 625 is 25. So what they tell you to do in Saxon is to do the prime factorization, right? And then when you get all of the factors, right, just go ahead and take the square root. So the square root of 5 to the 4th is 5 squared. Now, this is perfectly fine. You will actually need to know something like this starting tomorrow, okay? But for right now, I probably would just do this, right? 625 root. Okay? I would encourage you to learn how to do these on your calculators, right? The little blue ones have this little square root button, right? The thing is you do it after the number rather than before. Okay? So, I have no problem with you using your calculator tonight, but I don't want any decimals in my answers, except for maybe at the end, but I'll explain that to you. Now, we have a little property. I tried to get some color for you this time. Okay, so there's a property, and this is a very important property. It's going to come up a lot tonight. And that is if I have the square root of A over B, right, you need to understand that that is equal to the square root of A over the square root of B. Okay? And I want you guys to really make sure you understand this. Okay? Right? We know that B doesn't equal 0. Okay? So, what does that have to do with us? Well, let me move this paper up a little bit. Hopefully it'll focus for us. Okay? So, we'll have a problem that looks like this. What is the square root of 1 over 196? Well, by the property I just figured out, that's going to be equal to the square root of 1 over the square root of 196, which is 1 over 14. And that is the answer. So I would say that's a medium one. You really just need to know this property, right? So if I have the square root of A over B, that's equal to root A over root B. All right, so this next one I tried to make a little bit harder, okay? There's one like this on the homework, right? I think the answer is like 27 over 28. So here I have root 256 over 289. Now I did tell you, okay, that I know that 17 squared is 289, but by my property, I know that's equal to root 256 over root 289, right? And by the table I just did for you, I know that the square root of 256 is 16, and I know that the square root of 289 is 17. Okay? So, that's my answer. Plus or minus 16 over 17. Boom. Alright? So I'm about to get to the 11-minute mark, so I'm going to try and pick this up a little bit. Okay, so I have the next page here, if it'll come into focus. So, here I have this root 144 over root 441. Okay? So I'm going to try and do this in three ways. I don't know what the three ways I was thinking of, but let's go ahead and go slow. Okay, so the first thing I could do, right, is I could say that this is root 144 over root 441. Okay? So this is my first way, right? It's minus. Now, again, this is one I have memorized, but I know that 144 is negative 12, or is 12, and I know that 441 is 21, but in case you guys don't know that, 441 root is 21. So that's one, again, I have certain ones in there. So that's going to be 21, right? The problem is whenever I give a fraction, it has to be reduced, right? And this can both be divided by 3, right? So I get negative 4 over 7, which, by the way, is the answer. All right, now, I will tell you there is another way that I could do this. I'm trying to get to 3 if I can remember all 3. I'd love to use the color blue, but it looks like I'm stuck with... Oh, no, that's a Sharpie. All right, so I'm going to go with green for my next version. Okay, so this one is going to be the one that's going to lead to these other problems that are down here. Okay, as I look at 144, right, I know that that's a multiple of 9. And as I look at 441, I know that that's a multiple of 9. So I'm going to divide by 9 over 9. Okay? So 9 goes into 14 once. 9 goes into 54 6. 9 goes into 44 4 times. 9 goes into 81 9 times. So if I ask you for the root of 144 over 441, I can just reduce it, and it's going to be equal to the root of 16 over 49. Okay? So my answer here is negative root 16 over root 49. How do I know that? Because of the property that I learned in this chapter. So it's equal to negative 4 over 7. Again, same answer, different way. I like this one a little bit better, mostly because maybe you don't know the square root of 441 on the top of your head, right? But you can figure it out, right, if you reduce. Okay? The last thing that you might be tempted to do, and this is why I kind of have this as a cautionary tale, right? The third way that I would do this, okay? And I know that you guys are calculator junkies, especially now that I let you, so you might say this. Well, I know, right, 144 divided by 441 equals, okay? And then I hit the square root button, right? And so if you do that on your calculator, right, you get 0.571428, 0.571428, right, with a Repetan bar over it, right? So I will tell you, if you put this, right, I'm going to take off at least half credit because I don't like dealing with this, right? So you have a few choices. You could memorize, right, that 571428 is 4/7. You could say let x equal 0.571428 and then figure out that 1,000,000 x, right, is equal to 571428 blah blah blah, right? Or you could do one of the other methods. So I would not go straight to my calculator here, right? This is equal to -4/7, but I think it's a lot more work. I will not accept a decimal here, and I absolutely will not accept rounding, okay? So I would say this is the worst way to do it, okay? So I'm going to try and do these without a calculator if I can, except for the last one. I'll show you a little trick on that. All right, so then we have these hard problems. All right, so we move on to the hard problems. But if you remember method 2 here, that's all it is. So 99 over 44, well, I know that both of those are multiples of 11. So I am going to reduce, right, divide by 11. And I get that's equal to √9 over 4, which is √9 over √4, which is 3/2. Okay? So again, I don't think they're hard. It's just there's a little step. Sometimes it's hard to see what to divide by and things like that. So here we have 33 over 132. Okay, I will tell you, since I made it up, I know these are both multiples of 33. But let's say you didn't know that. So like, well, what goes into both? Well, this one is a multiple of 3. So I know that this is, right, I'll divide by 3/3. And I get 11 over 44. Well, these are both multiples of 11. So I divide by 11 again. And I get 33 over 132 is plus or minus √1/4, which I know is √1 over √4, which I know is plus or minus 1/2. Okay? So again, very doable. Things you should have seen before. This is really just a nice thing for you to know. And you should feel comfortable just changing it from this form to this form. But I can reduce it or not reduce it. Now, some of these get pretty hard, right? And you're going to probably need to use your calculator or want to use your calculator, whichever you choose. I don't mind if you use your calculator as long as you don't give me any answers as decimals. Bad. Okay? All right, so last one. Okay? So I was reminded of Indiana Jones and the Temple of Doom, and so he's in the square, and he's chasing after his girlfriend who's been kidnapped by the Nazis, and all of a sudden this guy jumps out of nowhere, and he starts waving this scimitar and going crazy with it and flipping it all around his head, and Indiana Jones just pulls out his gun and shoots him. So I'll show you the way the book did it, okay? The book says this, okay? So 1.21. Well, I just did a chapter where I learned that 1.21 is 1 and 21 hundredths. So this is equal to 1 and 21 hundredths. Okay? So that would be plus or minus √1 and 21 hundredths. Right? Now, I can change that to an improper fraction, so it's plus or minus 121 over 100. Okay? And now, I know by the property that I just learned that that's equal to √121 over √100. I know my perfect squares up to 20, up to 15, right? So you should know that this is plus or minus 11 over 10. So 11 tenths is plus or minus 1 1/10, which is plus or minus 1.1. So here they do want the answer in a decimal. Okay? So we'll say if it's given to you as a fraction, give it back as a fraction. If it's given to you as a decimal, give it back as a decimal. So here we have the guy waving the scimitar, right? 1.21, right? Change it to a fraction, right? Change the mixed number to an improper fraction. Use my square root rule, right? Get it to 11/10. Change it back to a mixed number. Change it back to a fraction, right? Whoosh, 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 whoosh. Or 1.21 root. I would go with this method, okay? If you want to do it the other way, that's fine. But again, you should feel comfortable, or I don't know if comfortable is right. I have no problem with you using your calculator here, okay? That's perfectly in the world of legality for these last 2 chapters. All right, guys, I went 1 minute long. Have a good Tuesday. I hope that you're getting ready for Holy Week. Miss you. That's a surprise to say. Miss 8A more than 8B. That's just honesty. Good luck, and hopefully see you soon.